Number sets you have been doing since Algebra 1, believe it or not. So you have natural, whole, integer, rational, and real. And then you do have irrational that's over here, his own little monster. All right. And so remember, you do have some letters you can use, like natural uses an N, whole, integer uses what is Z, rational uses a Q, real uses the R, irrational uses the I. All right. And if you don't remember those, you can just write the words, that's fine. Natural is your counting numbers, 1, 2, 3, 4, 5. Whole gives you a 0, 1, 2, 3, 4, 5. Integers your whole and their opposites, so that drops in negatives. Rational throws in your decimals and fractions. Real is really all of them at this point. Obviously, we did imaginary in chapter 5, but this is just of your real number sets. Irrational is non-repeating, non-terminating decimals. Those are usually things that you recognize like pi or square root of 5, the square root that doesn't have a perfect root. And so you should be able to recognize the number and what set it would be in. Whatever set it's in everything after that set, or above that set, I guess I should say. Meaning you find the smallest that it's in. Negative 14, the smallest that would be in would be integers, which means it's also in rational, it's also in real. All right, once it's in an integer, it's in everything that's larger of a set. The next sections, I actually put these two together. I put this section here that includes number 3 along with that section evaluate, because this is order of operations, all right? Order of operations, you're going to do your parentheses or your groupings, then you're going to do your exponents, then you're going to do your multiplication and division from left to right, whichever comes first. Then you're going to do your addition and subtraction from left to right, whichever comes first, okay? Order of operations. So whether I give you the numbers, like on number 3, 12 divided by parentheses 6 minus 5, parentheses 3 minus 3, or whether I give you variables and tell you what those variables are, here you're just going to plug those in and then do order of operations. Those are both simply order of operations. Remember, when you have multiple sets of parentheses, do the innermost first. So we would do the 3 minus 3, which actually is 0. Then we would do this, within this parentheses, the 5 times 0. So then we have 6 minus 0, then 12 divided by 6. So you would just do inside out if you have multiple sets of grouping. All right, grouping first. Within the grouping, do order of operations. Exponents, multiplication, division, addition, subtraction. All right, and that's true for this set or for this set. All right, we did do basic multiplication, division, etc. of rational numbers, meaning fractions and decimals. So I pulled just one of them. If you are adding and subtracting fractions, you need a common denominator. All right. If you are multiplying and dividing fractions, you do not. You are just creating more work for yourself if you get a common denominator. I pulled this one because this is one of the most common mistakes here. Remember, we keep the top guy, we change it to multiplication, and we flip the bottom guy. If any of these are mixed numbers, then please change it to an improper fraction. You will multiply incorrectly. You can multiply by mixed numbers, but it's actually distribution. You multiply the 3 and you multiply the 1/3, and nobody ever does that. So the easiest thing to do is to change it to an improper fraction. So I'm going to keep that negative 5 over 4. I'm going to change this from division to multiplication. This as an improper fraction, remember you multiply and add. So 3 times 3 plus 1, that would be 10/3. I'm going to flip him. So I'm going to say 3/10 here. All right. And then we're just going to multiply. You can multiply across. What else can I do when I'm multiplying fractions? I can cross cancel. So I can cancel this guy and this guy. Multiply across 1 times 3, 4 times 2. I had a negative divided by a positive. What is my answer? Negative or positive? Negative. So basic rules apply between positives and negatives as well. All right, so if we do number 3 together, I would do my innermost parentheses first, 3 minus 3. So I end up with 12 divided by 6 minus 5 times 0. All right. Then I'm going to do, let's move him up a little bit so I have more room. Inside the parentheses, I'm going to do this 5 times 0, which gives me 0. So inside my parentheses, I have 6 minus 0, which is just 6. So I have 12 divided by 6, which gives me 2. Exponential properties. I don't know why, but this is one thing that stumps people all the time, all right? Take it one piece at a time. The rules for your properties of exponents. If you multiply like bases, so I have base x to some power, base x to some power, you're going to add those exponents. If I divide like bases, you subtract those exponents. If I have a power to a power, so I have some power to some power, you multiply those. All right? If I have a group to a power, by the way, everything in the group gets taken to that power. So if I had a 3 in front of that x, the 3 would also be taken to the power as well, right? Anything to the 0 power, well, that equals just the number 1, not 1 times the x. It literally just equals 1 because it ends up being x over x. So it's just 1. Anything to a negative power, that just moves it. If it's in the denominator as a negative, it bumps to the numerator. It reciprocates it. In the numerator, it bumps to the denominator. So it just reciprocates that guy. Okay? When I look at something like this, I just chose the first one here. I'm really going to pay attention to what are like bases and what are my coefficients. So I'm always going to start with my numbers because this is multiplication. All right. And so I'm going to look at my numbers, my coefficients first. This guy just has a 1. So 1 times 4 times 3. I'm going to look at all of my coefficients there. Okay. And then I'm going to look at my a's. I have a to the 4th times a squared times a cubed. Those are my a's. And then I'm going to look at my b. I just have b to the 0 power. Okay. B to the 0 power is just the number 1. So this actually can be thrown over here with my numbers. B to the 0 power, he's just 1. So when I simplify this guy, I have 1 times 4 times 3, which is 12. These are all like bases, so I can just add those exponents, right? I can say 4 plus 2 plus 3, and I can get a to the 9th power, and I am done. All right, solving equations. Okay, so while we have not done just solving equations since this chapter, we've had to use it. We've had to use it in word problems. We've had to use it in, inequalities and in absolute values. So solving equations should kind of be second nature at this point, okay? When I have something like this, I have to distribute to get anything out of my parentheses. So think about what you have to do. I need to distribute to get rid of any parentheses here. I need to combine like terms on each side of that equation. And then I need to get my variable by itself. And then multiply or divide once the variable is by itself, right? And so you're going to think through that process every time you come to an equation, whether it's in a word problem or whether it's just standing alone like this. And so I am going to look at these. I can't simplify this side at all. It doesn't have any like terms for me to simplify. So I'm going to leave that side alone for right now. And then I'm going to look at that right side and I'm going to say, okay, the 7x I'm going to leave alone. I'm going to distribute to get these guys out. And then I can still simplify this right side. So I'm going to leave this left side alone. I am going to simplify this right side. And now I'm going to start shifting around. I'm going to get all my variables to one side, all of my numbers to the other, so that I can get this as simple as possible and then divide. So add my 4x over here. Add my 16 over here. And then I'm ready to divide. So I can just divide both sides by that positive 17. Divide by whatever is with your variable. X is going to equal -1, and I am done. Don't forget, for any equation like this, you can plug a -1 in and see if you got the right answer. You can check, right? You should plug it in and get a true statement. A number equals a number, right? And you should get a true statement if you did your answer correctly. And remember, when you plug it back in, you do order of operations to see if you got it correct when you did it. All right, 2 types of word problems we did in this chapter. We did distance, rate, and time. All right, so first of all, distance equals rate times time. And then we did mixture equations. And so the hardest part of these are just setting up the equations, right? Setting up your chart is typically the best way to do this. You have typically for your distance, rate, and time, you're going to have 2 things that are traveling. And so you're going to have your rate and your time that always equals your distance, okay? You want to look for a couple of things here. Opposite directions. Opposite direction tells you you're going to have 2 distances that you add up. When you see the word opposite direction, or if they're meeting, then you should look for a total distance apart, which they gave you right here. 760 or 7,640 meters apart. And so that's what we're looking for in these, all right? So we have a rate, we have a time, we have a distance, and we know that these 2 added up are going to equal our total distance apart once we get there. And so they've given us 2 things. They've given us Air Force, and they've given us a cargo plane. And then we're going to read through it. Left the airport 1 hour before the cargo plane. So we know that the Air Force plane is traveling longer. They flew in opposite directions. The cargo plane flew at 310 miles an hour. That gave me my rate. And then for 9 hours, and that gave me my time. What is the Air Force plane's speed? Well, we now know what we're solving for. And they said he left 1 hour before. So we don't even have to put a variable there. How long did the Air Force plane travel? Well, 1 hour longer than the cargo plane. So that's going to be a 10. Okay, if one traveled 9 hours and one traveled 1 hour longer, 1 hour longer than 9 is 10. Okay, so try to not read into it. Read the whole question before you start figuring out what needs a variable. Okay, because you're never going to have it, by the way, where it asks for a rate and you also have a variable for time. I'm not going to give that to you at this point. Okay, so you're never going to have a variable for rate and a variable for time with problems like this. All right, and then just multiply across for distance. 10R here, 2790. There we go. Once you have this, when it is distance apart and you have this little guy, total distance apart, you need to use him. These distances do not equal each other, okay? If they were traveling same direction or round trip, they equal. Opposite direction do not. So you're going to say 10R plus 2790 equals 7640, and then you're going to solve, all right? For the mixtures, you are also going to set up a chart, by the way. But for this one, you're going to have an extra line because you have an initial mixture and then you have a total mixture. So for these, you're going to have 2 different guys you're going to mix together, and then you have a final mixture. All right. And so these are similar but not identical, but they were in the same chapter here. So it's very easy to look and see what you have because they kind of tell you exactly what you have here. You have 2 brands of fruit punch, right? So we have brand A and we have brand B, and then we're going to have a total mixture. So your final guy here is going to be your final mixture, whatever that is. All right. And then they're going to tell you an amount. In this case, if I look, they are telling me in terms of gallons, all right? And then we have a percent of something. In this case, it's a percent of fruit juice, okay? And this last guy is going to be gallons of fruit juice. It's going to mix those two. Whatever the measurement was, percentage of what you have, and then the measurement of that whatever percentage was, okay? So for brand A, it says she mixed 2 gallons of brand A. Well, that goes here, 2 gallons of brand A. And 8 gallons of brand B, 8 gallons of brand B. This column always adds down. If I have 2 gallons and 8 gallons, I have 10 gallons total. That column always adds down. It says brand A is 42% fruit juice. So this is 42% fruit juice. Brand B is 52% fruit juice. What percent is the mixture? This column never adds down. Your percentages do not add down. And they actually say what percent is the mixture. That's what we're looking for right there. What percent is the mixture? Okay. For this, it also multiplies across. So just like your distance, rate, and time, this guy multiplies across. So we're going to say 2 times the 0.42. All right, we're going to say 8 times the 52. And then 10 times the x. All right. And then you're going to add down. These two always equal this guy. So we have the 0.84 plus the 4.16 equals the 10x. And then you're just going to solve. I will say for this, pay attention to what you're looking for. If you're looking for a percentage, then your answer needs to be in percentage, meaning when you take this, you're going to get a decimal, but you need to change it. So when you solve this, this equals 5, divided by 10 is 0.5. To get that to percentage, remember you have to multiply by 100. So this is going to be 50% juice. 50% juice when you're done. Couple things about inequalities. They are identical to equations, except when you multiply or divide by a negative. That's the only difference. So I am going to distribute just like I did with the equation. I am going to combine my like terms just like I did with the equation. I'm going to move my numbers to one side, my variables to the other with addition and subtraction. Then I am going to divide. And at that point, if whatever a coefficient is in front of your variable, if that is negative, then you will flip. If that is not negative, your sign will stay the same. And so I would recommend that you do this off to the side. Some of y'all try to do it at the top and you mess up. So make sure you do your distribution somewhere where you can see it. Make sure that if you're distributing this guy, that's a negative you're distributing. So multiply your negatives correctly. And then when you combine like terms, if they are on the same side, you don't do opposite signs, okay? So if they're on the same side, you leave them, meaning you don't change signs until you move them across. So you'd say 21 minus 16, 35 plus 12. And then you would simplify, subtract and divide. The other difference here is that you are also going to graph your equation. And so when you graph it, you want to make sure that you graph it accordingly. So open and close signs are important. So in this case, divide by that 5, you get P is greater than or equal to -3. If you look back at your number line, which is now way up there at the top, and it won't let me grab it. On your number line, make sure that you open and close circle correctly. So in this case, we're going to have a closed circle at -3. It is greater than -3, so we're going to shade everything to the right. So remember, absolute value has 2 answers. Before you set up a positive negative, you have to get the absolute value by itself. So before I do anything, I'm going to add this 10 over. So I have the absolute value of 10m minus 7 equals 67. Then I'm going to set up 2 equations. I'm going to say 10m minus 7 equals 67. 10m minus 7 equals -67, and I'm going to solve. Okay? You do not set up positives and negatives before that absolute value is by itself. Same thing for inequalities. Before I do anything down here, I am going to divide both sides by that -2, okay? I have the absolute value of -3b minus 7. I divided by a negative, so that guy flips. -22 divided by -2 is +11. Now I'm going to set up 2 inequalities, all right? I'm going to say what's inside, exactly the way it looks, greater than 11. And then what's inside, flip this guy, change this guy to negative. And then solve your inequalities just like you solved the inequality before, okay? So get the absolute values by itself before you set up 2 equations. before you set up two inequalities. Get it by itself first. This is asking us, this is telling us this is a relation represented as a graph, and then determine if the relation is a function. They are actually just asking you to plot those points and tell me if it is a function. So everyone should know how to plot a point. First value moves you left and right, second up and down. If it is a function, you will notice that your x's do not repeat. However, on this one goes to -4 and one goes to 6. So when you plot those, it's not going to be a function, all right? If your x repeats, it is not a function. So you should know how to graph points, plot the points, and tell me if it's a function or not. Functions have a one-to-one relationship from x to y. All right. The next set is asking us about relations and functions again. In this, however, they're asking for a mapping diagram. Remember your mapping diagrams. You're going to have to put your domain and your range, list them least to greatest, and do not repeat your numbers. Make sure you label your domain and range. You're going to list your x values from least to greatest in the domain, list your y values least to greatest in the range, and then you're going to draw your arrows from your x to your y values. And once again, if your x goes to more than one y, it is not a function. You can have multiple x's go to the same y, that's fine. So you should be able to graph relations on coordinate planes. You should be able to do a mapping diagram of relations, and you should be able to tell me if those are actual functions. Do they have a one-to-one? Evaluate functions. Evaluate just means plug it in and solve. All right, so function notation looks like this. If they want us to find f of -1, they want us to plug -1 in. -1 cubed plus -1. All right, and so if it says evaluate, you're just plugging that in for your variable, and you are giving me an answer. Your answer is just the numeric value that happens when you plug it in and solve. All right, so evaluate is very simple. It just means plug it in and solve. So it wants x and y intercepts, and then it wants us to graph. X-intercept is when your y is 0, so it ends up being, if it's in standard form, this is A, this is B, this is C, ends up being C over A. Y is your constant over your y coefficient, and your slope is always going to be your -A over your B. All right? So in this case, my x-intercept is going to be -2 over 1 or -2, 0. My y-intercept is going to be -2 over 2. And my slope is going to be -1 over 2. All right. Once I have these 2 points, I can just graph it. -2, 0, that's my x-intercept. 0, -1, that's my y-intercept. Once I have 2 points for any line, I can go ahead and graph that line. And so I'm going to just draw a line through the 2 points, arrows on either end, and I have graphed it. All right. For this one, slope-intercept form is what the first two are asking for. You should know slope-intercept form, y equals mx plus b. If you have a point and the slope, you can either plug that into y equals mx plus b and solve for b, or you can use your point slope, y minus y1 equals m times x minus x1. But your final answer needs to be in this format, y equals mx plus b, because it's asking for it. So y minus your y1 equals mx minus your x1. Distribute your 7 and add your 3 over. So for this one, you're going to get y equals -7x minus 4. That is your answer. The difference here is they did not give you your slope. So when they didn't give you your slope, you need to find your slope. So you do need to know your slope formula. Subtract your y's over subtract your x's. Once you have your slope, you do exactly what you did before. You can choose either of those points. Either of those points to plug it into this and solve for slope-intercept form. So you must know slope-intercept, y equals mx plus b. You must know your slope, y2 minus y1 over x2 minus x1. Your point slope just helps you get to your slope-intercept. You can plug a point and your slope into slope-intercept and find your b. Just make sure that if you do it that way, you go back and write it with your slope and your b filled in. That's the final answer that I'm looking for. So you have to have your slope, you have to have your y-intercept to put it in slope-intercept form. The last one on this page is asking for standard form. Standard form is the way you just graphed. That's ax plus by equals c. For this one, you can use point slope if you want to. You do need to have your slope. So you do need to use your slope equation to solve for slope with the 2 points. And then you use either of these to put it in standard form. But instead of leaving it in y equals mx plus b, you're actually getting your x's and y's to one side and your numbers to the other. All right? So for this one, I would find my slope. y2 minus y1 over x2 minus x1. All right. And then I'm going to do something different with my point slope. You can still start with point slope. That's fine. Y minus y1 equals m times x minus x1. All right, the difference here is you want your x's on one side, x's and y's on one side, and you want your numbers on the other, and you also don't want any fractions, all right? So when you do something like this, you've got to multiply everything by this denominator to get rid of those fractions. So I'm going to multiply this by 6. I'm going to multiply this by 6. I'm going to multiply this by 6, and I'm going to multiply this by 6. And so I'm going to end up with 6y minus 18 equals x minus 6. Or minus 1, sorry. 6 times 1, 6. All right. And then I actually want to move my x and y's to one side. So I'm going to move this x over here, negative x plus 6y. I'm going to move this 18 over here equals 17. The last thing about standard form, besides the fact that there are no fractions, your coefficient in front of your x is always positive. So if you'll notice on your answer key, all of your coefficients of x are positive, okay? Well, how do I make it positive if it ends up being negative? Just divide everything by -1. Divide by -1, divide by -1, divide by -1. You'll always want your coefficient in front of your x to be positive. So no fractions in standard form, and your coefficient in front of x is positive. So I end up with x minus 6y equals -17. And so if you get a different answer on your, and you look at your answer key and you have fractions, you probably need to get rid of your fractions. Or maybe everything's the opposite sign. All right? Your answer looks identical to the answer key when you check it, but it's the wrong signs. You should have divided everything by -1. So equations are just going to be lines. If you have a greater than or a less than, you are going to graph the shade of it. So you're going to shade it, okay? So when I look at something like this, you should know how to graph an absolute value. Absolute value is always going to be a V. And then you are moving it how you're supposed to move it, left or right, up or down. So inside's going to move it left and right. Outside's going to move it up and down. And so this is going to move the V left 4, and it's going to move the V down 1. So I'm going to take it from the origin, go left 4, down 1. That's where my vertex will be. And so I'm going to draw my V right here. And because it is an equal sign, I'm done. The difference between that and this one down here is that I need to shade it. Okay, so I'm going to move left 3 and down 2, and I'm going to draw that same V. The difference is I have to consider the inequality. This is just greater than. So with inequalities, I decide if it's dashed or solid, and I decide if I shade above or below it, okay? So dashed or solid, this guy is going to be dashed. Why? Well, I don't have an equal to sign. And so I'm going to go over 3 down 2, and I'm going to draw my absolute value v, but I am going to dash it because it is not or equal to. And then I need to decide how to shade it. Greater than. So I'm going to shade above it, which means it's going to shade up here above my v. You're going to do the same thing with your lines. Graph these lines just like you graph the other one. Find your x and y and then decide if you're going to graph above or below it, all right? So if I got my x-intercept is going to be negative 20 over 4. So my x-intercept is going to be negative 5. My y-intercept is going to be negative 20 over negative 5. That's going to be positive 4. It's going to be a solid line because it's or equal to. Now this one, because it's in standard form, I have to look at what is in front of this guy. Normally you would think you would shade below it, but that negative, if I were to put it in slope-intercept form, would flip this sign. So for this guy, you actually shade above it because it flips. There's a negative in front of the y, it's going to flip. If there's a positive in front of the y, it wouldn't flip. You have to know your distance formula. So if you don't, you need to make sure you go back. Distance is going to be the square root of your x's subtracted and squared, your y's subtracted and squared. Distance formula. You have to know your midpoint formula. Your midpoint formula is what happens when you add your 2 x's and divide by 2, add your 2 y's and divide by 2, and your midpoint is a point, xy. All right? xy, you have to have a midpoint there. Slope-intercept form of the equation kind of combines all of these. Well, the midpoint at least. Perpendicular bisector, you have to find your midpoint. That's the point you're going to use. You have to find your slope of this. And then remember, it's the negative reciprocal of that slope if it is perpendicular. So you're going to find your point using your midpoint. You're going to find your slope between the 2 points, but it's negative reciprocal because it's the perpendicular bisector. And then you can go all the way back to your point slope that we used and find your equation with this point and this slope. So you're kind of combining everything when you do that particular type of problem. In chapter 3, we solved multiple methods of solving systems of equation. The first method was to solve by graphing. When you solve by graphing, you graph these 2 lines and where they cross is your answer. These are in slope-intercept form. So remember with slope-intercept, you start at your intercept, negative 3. You move by your slope. The slope is positive 1, so up 1 over 1. And then you're going to graph that particular line. If I can get it to graph, that's good. I'm going to keep doing this. Once you do that, you're going to graph your next line. Same way, start at your y-intercept, walk by your slope. Negative 4 over 1 goes down 4 and over 1. That's where this guy crosses. If you don't see exactly where it crosses, you can walk. By that I mean you can walk your slope up or down. Once you see where they cross, that is your answer. That is the answer to that systems of equations, solved by graphing. So you're going to go right from linear equations to solving by graphing. The other ways that we solved in this particular one was substitution and elimination, all right? Substitution is exactly what it sounds for. You substitute. So you're going to take one variable by itself and plug it into the other one. So that's already by itself. Plug it in and solve. Remember, for all of these, your answers are x's and y's. So in this case, I would solve for x first. And then once I have x, I have to plug it in and solve for y, okay? So it doesn't matter which variable you solve for first. But for all of these, you should have an X and a Y answer. XY is your answer. The other way that we solved was elimination. For elimination, one of your variables needs to be opposites. This particular example it is. If it were not opposites, I would have to multiply by something to make it opposites. Once you have one variable that are opposites, it's basically addition. -1 and -2, these cancel. Once you have your X value or your Y value, depending on what you solve for first, plug it back into either equation. Your answer should be an X and a Y. Okay, so we solve by graphing, by substitution, and by elimination. And once you have that one variable, you have to then go in and solve for. Systems of inequalities is just two inequalities that you have. I know that seems pretty straightforward, but just like you graphed your inequalities in the prior chapter, you're graphing two inequalities. Where they cross each other is your answer. So you're going to take these and you're going to graph these lines just like we graphed them at the beginning of this particular chapter. We're going to start at -2. We're going to go up 1 over 2. In this case, it is an inequality. I have to decide, am I dashing or am I making it solid? In this case, dashing because it's just less than. And then I'm deciding where I'm shading this one. Well, I'm shading below because it's less than. I'm going to do the same thing on the next one. Start at +3. Go down to an over 1. Is it solid or dashed? Well, this particular one is solid. And then where am I graphing? Above or below? Well, this one is also below. So that's this part. And then you look and say, where did they cross? That is my final answer for this. And so you want to make sure that you tell me where your final answer is, where those two cross each other. All right, so I'm looking for, did you graph the line correctly with your slope and intercept? And did you make it solid or dashed correctly? Did you shade correctly? So I'm checking those things when I'm doing these. All right, simplify, it can be anything. It can be as basic as just distribution, right? If there's a number in front, you're literally just multiplying everything inside by it. The only thing I would say is watch your positives and negatives. All right. Addition and subtraction, you have to have the same dimensions to be able to add and subtract. But if you have the same dimensions, add each element to itself, to the corresponding element, or subtract. Again, if it's subtraction, watch your positives and negatives, right? And then multiplication. This is the one where is more difficult, okay? So if it's multiplying 2, remember you're multiplying row by column, all right? And so first of all, can you multiply? You have to check your dimensions. If you can multiply, these will be the same. The inside dimensions will be the same. The outside dimensions tell you what your answer will be. And so my answer is going to be a 2 by 2. I'm going to say -3 times -4 plus 0 times -1. My next one's going to be -3 times +3 plus 0 times 0. Once you get to that second column or your last column, you're done with that row. Go to the next row. -5 times -4 plus -4 times -1. And -5 times 3 plus -4 times 0. And then you're just going to simplify. All right. Simplify these. +12 plus 0. -9 plus 0. +20 plus 4. -15 plus 0. And my answer is just going to be those when I simplify them. 12, -9, 24, and -15. The goal of solving an equation is always to get the variable by itself. In this case, however, the variable is a matrix. And so you are solving for a matrix. So in this case, I would add this matrix over, and then I would divide by -2. Okay, so it's identical to what you're doing when you're solving an equation. Do the opposite to solve for the variable. All right? So add your matrix over to this side, then divide your answer by -2. Your answer will be a matrix. Okay? Determinants are diagonal minus diagonal. Don't forget it's always subtraction there. All right. 3 by 3s, you can either do it, there's two different ways. You can shift these over and do your diagonal plus diagonal plus diagonal, and then subtract the other way, diagonal, diagonal, diagonal. Or you can do it the other way where you do, I would actually do this row, this column right here and do your 2 by 2s of your ones that are left over. All right. But you do need to find determinants for 2 by 2s and 3 by 3s. So if you need to refresh, go back to your notes on those and make sure you know how to do. For Cramer's rule, don't forget you have a coefficient matrix, all right? So you do your coefficients and find him. Then you're going to replace the first column with your answers. That 18 and 5 replaces that first column, and you're going to have an X matrix. And then you're going to have a Y matrix. Replace the second column with those answers. So you end up with 3 answers. You end up with a coefficient matrix, with an X determinant, with a Y determinant. And remember to get your actual X and Y. X is going to equal the X determinant divided by your coefficient determinant. Your Y is going to be your Y determinant divided by your coefficient determinant, okay? So this is yet another way to solve systems of equations, doing 2 by 2 determinants. All right, so the first step is to find all 3 of those, and then you divide these by your original coefficient to find your actual answers. then we are in chapter 5. We just did chapter 5, okay? One thing I saw is some of you wanted to FOIL and then factor back. If I am asking for the product, just FOIL and simplify, okay? I've given you it in factored form. So some of you gave me the answer that I started with, right? So if it's find the product, this is just FOIL. FOIL and combine your like terms. All right, so we're just going to do first, outer, inner, last, combine my like terms. I am done, okay? Factor, that is where you're going the other direction. So remember, you want to take out your common factor first. Take out your common factor. Then you're going to break it up into two binomials. It just depends on what happens at that point. Like this guy, you can take a 5x out of, okay? And so when I take a 5x out, I'm left with x squared minus 13x plus 42. And when I have just an x squared, all I have to worry about is factors of 42 that add up to 13, okay? So I can just go straight to my 2 right here. All right, I did negative, negative because I wanted a positive 42. And then I wanted a negative 13. So to multiply to get positive 42, add to get negative 13, I had to do negative 7 and negative 6. And I'm actually done. If you take a common factor out, it needs to stay there. It needs to stay in front. If, though, when you take your common factor out, or let's say it doesn't have one, and you have a coefficient here in front of that x squared, that's when you want to multiply across. 3 times negative 2 is negative 6. Factors of negative 6 that add to give you 5 are positive 6 and negative 1. This is where I'm going to rewrite it. 3x squared plus 6x minus 1x minus 2. I have 4 terms. I'm going to factor by grouping. Group this, group this. When I group behind a negative, I change the last guy. Take out what's in common. This guy has a 3x in common. If you don't have anything in common, just put a 1 out there. When you factor by grouping, this is what should happen. Your groups should be the same. Since my groups are the same, I'm going to take that group out. What is left over is my other group. And so I am done with that factoring. So 2 types of factoring when it's a trinomial. Either you just have a 1 at the very beginning and you only have to worry about the last one. You can go straight to your 2 parentheses. Or there's a number in the front and you need to multiply across and do your factoring by grouping. I could also give you 4 terms and you start factor by grouping immediately. But always look for a common factor. Always look for a common factor first. All right? If it has an addition or subtraction, add or subtract your like terms. So add or subtract your like terms. That's all you're doing. You are not foiling here. You are just combining your like terms. If it looks like this is a foiling. Multiply. Multiply all the way across. All right? So pay attention to what it is asking you to do. The only difference here is I squared equals negative 1. X squared does not change. If it is an x and you're foiling, your answer will have an x squared. But if it is an I and you have a square, then it just changes this sign from positive 36 I squared becomes negative 36. And now I have like terms. I have a 2 and a negative 36. That's negative 34. I have a negative 12i and a negative 6i, negative 18i. And so I can combine those. Solve by factoring. We just factored. But in order to solve by factoring, it must be equal to 0. All right, which means I have to move this 8 over. Have to move it over. And then I do my same rules. If there's a 1 in front, look at the last guy and factor. If there is something other than a 1, then you're going to have to use your method where you multiply across. Once you factor, you are not finished. You have to set each factor equal to 0 and actually solve for what x is, or what k is in this case. So your answers will be numeric here when you're solving. You will have numbers as your answer. You won't have variables. We also solve by taking the square root. When you're solving by taking the square root, you want to get that x squared by itself. So you need to move everything out of the way. Which means you add or subtract, and you also have to divide. So I have x squared equals 12. Which means I need to take the root of 12. I have to take the root of both sides. It also means that I have to consider the positive and negative root, and if my root can simplify. All right? And so remember how to simplify as well. Okay, so finding the root's not hard. Get it by itself, simplify. If it's a negative in the root, part of your simplifying is to take that negative out with an I. All right? When it says by any method, which is the last section here, if I'm going to look at something like number 155, I'm going to immediately solve by factoring because it's a really easy factoring. X plus 5, x plus 1. Set each one equal to 0. All right? If it's something like 156, I'm not even going to bother trying. First of all, this is not factorable. But I'm not going to spend 30 minutes trying to figure out if it is. I'm going to go straight to my quadratic formula. Make sure it's equal to 0, just like with factoring. This is my A, this is my B, this is my C. And make sure you know your quadratic formula. Plug it in. If you can simplify your radical, simplify it, reduce it, and you're done. Okay? So you do need to know your quadratic formula because there are going to be some like this. This actually ends up being imaginary with a radical in it. You're never going to be able to solve it another way. You're going to want to solve it with the quadratic formula.